Students, the question 10a says differentiate x ln x minus 2x with respect to x, and we have to simplify our answer. So we'll first write for 10a that y equals to x ln x minus 2x. So we'll be using product rule over here. So that means this is my u, this is my v. So if I'm writing for the product rule, so y equals to u into v. So if I'm finding the derivative y dash, so that has to be u into v dash plus v into u dash. So where dash is the derivative. So that means if I'm finding the expression for dy by dx over here, so it should be x into derivative of ln x, which is 1 by x, plus ln x into derivative of x, which is 1, and that's minus of 2x. So the derivative is minus 2. So that means we can remove this x, and so that is 1 plus ln x minus 1 minus 2. So the final answer is ln x minus 1. So that's the final answer for the 10 part A, and according to the mark scheme, so you get it correct, 2 marks for writing the final answer form. So now moving on to the B part of the question, they have clearly said that the value for d2y dx2 is equals to x plus 1 whole square, and it's given that dy by dx equals to e square by 2 plus 2e at these points for x and y. So we have to, using our answer in part A, find the exact equation of the curve. Now, if d2y by dx2 is given to me as something like this, so we'll first put up the general form, which is x squared plus 2x plus 1 over x. So which can be written as x plus 2 plus 1 by x. So that's the simplified form that we have found for d2y by dx2. Now if I'm integrating both sides of the function, so we'll get it here. So if I integrate both sides with respect to dx, so I will get here as dy by dx, because the integration of second order gives you the first order derivative, and the integration that I'll be getting over here is x squared plus 2 plus 2x, and this is plus ln x plus an integral constant c. Now the value of dy by dx they have given in the equation, which is e squared over 2 plus 2e. So, and that's equals to the value of x squared again over here is e squared over 2, and that's again 2e, and plus ln x, so that's ln e, and plus the integral constant c. So that means e squared plus 2e gets cancelled. So c becomes minus of ln e. So that's equals to minus of 1. So that's the value of the integral constant c that we got from here. So that means our equation for dy by dx now becomes equals to x squared over 2 plus 2x plus ln x, and that's minus 1. So now if I want to get the equation of the curve, I have to integrate again both sides with respect to dx, so that the first order derivative will now become y, and that should be equal to x cubed over 6 plus x squared. Now the derivative of ln x should be done through by parts. So derivative of ln x minus 1, here we are using the first formula where we got it as x ln x minus 2x. So we can put that result directly. So that's x ln x minus of 2x, and that should be plus k. So that's the form that we got for y. So again, x and y coordinates should be satisfied by this. So that means we got it as e cubed over 6 plus e squared, and that should be equal to e cubed over 6 and plus e squared plus e ln e minus 2e, and that should be plus k. So these two parts get cancelled from both the sides. So we got it the value of k as equals to positive e. So the final equation that we got is y is equal to x cubed over 6 plus x squared plus x ln x minus 2x and plus e. So that's the final answer of the equation of the curve for this particular question. Now, if I go by the marking scheme of the question, so you get 1 mark for writing this step correctly. So if you've written this, so you get another 2 marks for writing dy by dx correctly over here. So the calculation if we move ahead, so the calculation of c equals to -1 gives you 1 more mark. Again, integrating and putting this form, you get a mark for this. Uses plus c, so writing this step gives you another mark, and then calculating the values of ks correctly, 1 more mark. So, and the 1 mark for the final answer, writing it correctly. So this is how the marking scheme of this question works. Thank you, students.